The Moon, our closest celestial companion, has captivated humanity for millennia. Its presence in our night sky has inspired countless myths, legends, and scientific inquiries. From ancient civilizations to modern-day astronomers, the Moon has always been a source of wonder and fascination. It illuminates our night sky and governs the tides, creating a rhythmic dance with the Earth that affects our oceans and coastal ecosystems. But the Moon is not just a passive orb reflecting sunlight. It is a dynamic world with its own unique characteristics and phenomena. It is a dynamic world with its own geological processes, including volcanic activity in its distant past and the constant bombardment by meteoroids that shape its surface. One of the most intriguing phenomena is the occurrence of moonquakes. These seismic events reveal that the Moon is not as inert as it might seem. These seismic events, while less frequent and intense than their terrestrial counterparts, offer valuable insights into the Moon's internal structure and history. By studying moonquakes, scientists can learn about the Moon's composition and the forces at play beneath its surface. Unlike Earth, where tectonic plates constantly shift, the Moon's surface is relatively stable. This stability provides a unique opportunity to study seismic activity in a different context. So what causes these lunar tremors? The answer lies in a combination of factors, including the gravitational pull of the Earth, thermal expansion and contraction, and even the impact of meteoroids. Let's delve into the fascinating world of moonquakes and uncover their secrets. By analyzing the data collected from lunar missions, scientists are piecing together the puzzle of the Moon's seismic activity. The Moon's desolate beauty hides a surprisingly active geological past. Its surface, marked by craters and mountains, tells the story of a world that has experienced significant geological changes. By studying moonquakes, we can begin to unravel the mysteries held within. Each tremor provides a clue to the Moon's internal structure and the forces that have shaped it over billions of years. The causes of moonquakes are varied and intriguing, each telling a story of the forces shaping our lunar neighbor. From the gravitational interactions with Earth to the thermal dynamics within the Moon itself, these quakes offer a window into the complex and fascinating world of our celestial neighbor. For centuries, we gazed at the Moon, assuming it to be a still and silent world. However, the dawn of the space age brought about a groundbreaking discovery. The Moon experiences quakes. This revelation shattered our previous perceptions and ignited a thirst for understanding this lunar phenomenon. Unlike Earth, where earthquakes are primarily caused by the movement of tectonic plates, moonquakes originate from different sources. These include the gravitational pull of Earth, meteoroid impacts, the Moon's internal cooling and contraction, and even the thermal expansion and contraction of its surface. Each moonquake, regardless of its cause, sends seismic waves rippling through the lunar interior. By studying these waves, scientists can glean valuable information about the Moon's composition, revealing its hidden layers and secrets. One of the primary causes of moonquakes is the relentless pull of Earth's gravity. This gravitational force is a constant, unyielding presence that shapes the very nature of our lunar companion. Just as the Moon's gravity tugs on our oceans, causing tides, creating the rhythmic rise and fall of sea levels that we observe daily, Earth's gravity exerts a similar force on the Moon. This force is not just a gentle pull, but a dynamic interaction that influences the Moon's structure. This gravitational dance between the two celestial bodies creates tidal stresses within the lunar interior. These stresses are like invisible hands kneading the Moon's insides. These stresses, particularly pronounced at certain points in the Moon's orbit, can cause the lunar crust and mantle to deform, leading to deep moonquakes. The deformation is a slow but powerful process reshaping the Moon's internal structure. These quakes, originating hundreds of kilometers below the surface, are a testament to the powerful forces at play in our cosmic neighborhood. They remind us of the dynamic and ever-changing nature of celestial bodies. Imagine the Moon's interior slowly being stretched and compressed by this invisible force. It's a process that happens over eons, gradually altering the Moon's geological landscape. Over time, this can create fractures and shifts, releasing energy in the form of seismic waves that we detect as moonquakes. These seismic events provide valuable insights into the Moon's composition and the forces that shape it. The Moon, lacking a substantial atmosphere to shield it, endures a constant barrage of meteoroids. These cosmic projectiles, ranging in size from tiny grains to massive boulders, slam into the lunar surface with tremendous force. Each impact sends shockwaves through the Moon's interior, triggering moonquakes. These impact-induced moonquakes, while generally weaker than those caused by tidal forces, provide valuable information about the Moon's subsurface structure. By analyzing the seismic waves generated by these impacts, scientists can map the distribution of different layers within the Moon's crust. Every impact crater on the Moon is a testament to these cosmic collisions. They serve as a reminder that the Moon is not a static object but a dynamic world constantly shaped by external forces. Section 5. Internal cooling. The Moon's shrinking heart. Deep within the Moon's core, a slow cooling process has been underway for billions of years. As the lunar interior loses heat, it contracts, causing the entire Moon to shrink slightly. This contraction generates stress within the lunar crust, leading to shallow moonquakes. These quakes, originating closer to the surface than those caused by tidal forces, provide insights into the Moon's thermal evolution. By studying the frequency and distribution of these shallow moonquakes, scientists can learn about the Moon's cooling rate and its implications for the lunar interior. Imagine the Moon as a slowly cooling ember, its outer layers cracking and shifting as the heat dissipates. Each crack and shift releases energy, creating the seismic waves we detect as moonquakes. Section 6. Thermal expansion and contraction, the Moon's breath. The Moon's surface experiences extreme temperature variations between day and night, creating a dramatic thermal environment. During the lunar day, which lasts about 2 Earth weeks, the surface can reach scorching temperatures of over 120 degrees Celsius. This intense heat is due to the lack of an atmosphere to diffuse the sun's rays. Conversely, during the equally long lunar night, temperatures plummet to frigid lows of -170 degrees Celsius. The absence of an atmosphere means there is no insulation to retain the heat. This constant cycle of heating and cooling causes the lunar surface to expand and contract. Like a breath taken over a day, the surface rocks swell and shrink, creating a dynamic environment. This thermal stress can lead to shallow moonquakes, particularly in regions with large temperature differences. These moonquakes, though not as intense as earthquakes, still play a significant role in shaping the lunar surface. The Moon's surface is a tapestry of extremes, from the scorching heat of lunar noon to the frigid cold of lunar night. These temperature variations create a unique and harsh environment. This constant thermal dance shapes the lunar landscape and generates seismic activity that we are just beginning to understand. The Moon's breath, a cycle of expansion and contraction, is a testament to the dynamic processes at play on our celestial neighbor. Section 7. Unveiling the secrets types of moonquakes. Moonquakes are broadly classified into 4 main types: deep moonquakes, shallow moonquakes, thermal moonquakes, and meteoroid impact-induced quakes. Each type provides unique insights into the Moon's structure, composition, and geological processes. Deep moonquakes, as their name suggests, originate deep within the lunar interior, likely caused by tidal forces. Shallow moonquakes, on the other hand, occur closer to the surface, driven by the Moon's internal cooling and contraction. Thermal moonquakes result from the extreme temperature variations on the lunar surface, while meteoroid impacts generate seismic waves that propagate through the Moon. By studying these different types of moonquakes, we gain a more complete picture of the Moon's dynamic nature and the forces that have shaped it over billions of years. Section 8. Listening in, the Apollo missions and moonquakes. The Apollo missions, humanity's first foray to another celestial body, played a pivotal role in our understanding of moonquakes. The Apollo astronauts deployed seismometers on the lunar surface, instruments designed to detect and record seismic waves. These seismometers provided a wealth of data, revealing the surprising frequency and diversity of moonquakes. The Apollo missions confirmed the existence of deep moonquakes, likely caused by tidal forces, and shallow moonquakes, attributed to the Moon's cooling and contraction. The Apollo missions were a testament to human ingenuity and our thirst for knowledge. The data collected by the seismometers continues to provide valuable insights into the Moon's hidden depths. Section 9. Moonquakes in the future, building a lunar home. As we venture back to the moon, this time with the ambition of establishing a sustained human presence, understanding moonquakes becomes crucial. The design and construction of lunar habitats and infrastructure must consider the potential risks posed by these seismic events. Detailed lunar seismic hazard maps, based on data from the Apollo missions and future lunar missions, will be essential for selecting safe landing sites and designing resilient structures. By studying moonquakes, we can ensure the safety and sustainability of future lunar settlements. The moon, once a distant object of wonder, is becoming a new frontier for human exploration and settlement. By understanding its secrets, including the mysteries of moonquakes, we can turn this vision into a reality.